did go through it. So this is the May-June exam 2019 supplement. How I don't think it's supplementary exam, but some people when they're like improving their marks, they write their exams in June. So this is sort of like a final exam, but in the middle of the year for people who are improving their marks. So they say 1.1, a car is moving at constant velocity. Which one of the following statements about forces acting on the car is correct? So here, you're just going to look at the first thing, that when the velocity is constant, that means your acceleration is constant. So basically, you're just going to relate velocity to force. If v is constant, that means the change in velocity is 0. And when the change in velocity is going to be 0, we know our acceleration is the change in velocity divided by the change in time. So when the change in velocity is 0, your acceleration is automatically going to be 0. And what's going to happen to the net force?
It's also going to be 0, sir.
Okay. So yeah, the net force acting on the car is 0. So here they're just saying there are no forces acting on the car. That's a lie because the car is actually moving. So there is a force applied. And here they say the weight of the car is equal to the normal force, which is true. But they want a statement about all the forces. So they say there is a non-zero net force acting on the car, which is completely that's gonna be wrong. So they say a ball is projected vertically upward. We're gonna ignore air resistance in this situation. Which one of the following statements about the acceleration of the ball at its maximum height is correct? So when you're on Earth and you're gonna throw something up, ignoring air resistance, because that's the only other force that can affect that object's motion. Why do you think the object is accelerating this entire time? Like you can just say the letter, or you can tell me what's happening. So what do you think like the answer is gonna be?
I think it's B.
Because if you're gonna ignore any other forces, and this is gonna be projectile motion, that means the ball is in free fall in a way. Even though it's going up, there's no other forces acting on it. It's just that the initial force that you used to throw it up. So the only force acting on it is going to be the force of gravity, and the acceleration of the force of gravity is always downwards to Earth. So let's go. So the graph below, which is not drawn to scale, shows the relationship between the gravitational force and the given mass and its direction from the center of the Earth. The magnitude of the force on the mass at the distance r from the center of the Earth is F. So at distance r, the gravitational force is F. And they say which one, and at the distance 2r, the gravitational force is a quarter of F. And now we have to find out the gravitational force at GR as 6r. So they say which one of the following is correct to represent X. So here you can just use Newton's law of universal gravitation, or you can use the relationship between the force and the distance. So you know that force is inversely proportional to the distance squared. So basically here you have 2r. That's why your force is 1/4. Oh yeah, sorry. This is directly proportional. So it's inversely proportional to the distance squared. So here, you're just gonna substitute your 6r into that. So you're gonna have your F might be equal to 1 over into 6, the whole thing squared, F. Because this R, the magnitude at R is F. So when you write 6R, you don't have to write this F. But when you don't write the R, you have to write this F. So basically, from these calculations, you know that your answer is gonna be D, which is 1/36F, because 36 is the value of 6 squared. So I'm pretty sure like this is easy. It's not that complicated, right? I don't think it's that difficult. So do you understand that?
Yes, sir.
Yeah, so here now this is a question. So I'm gonna answer a question, you're gonna answer a question, I'm gonna answer a question. So let's just swap. So they say ball M moving at a velocity at a speed of v to the right collides with the stationary ball N on a smooth horizontal surface. After the collision, so after the collision, ball M comes to rest, and ball N moves to the right with a speed of v. So same time you hear that the surface is smooth, they're basically telling you that there's negligible friction between the ball and the surface. So they say which one of the following statements about the collision of the ball is correct? The total momentum is conserved and the masses of the balls are unequal. The total kinetic energy is conserved and the masses of the balls are unequal. Total momentum and total kinetic energy are conserved and the masses of the balls are equal. Total momentum is conserved, but kinetic energy is not conserved, and the masses of the balls are equal. So, which one can you say is correct? So, do you need like a few minutes or a few seconds just to think about it?
Yes, I just need like 2 seconds. Just think quickly.
Okay. Let me just get like a timer here because this is a 20-mark question. So let's say for each question, you might need 2 minutes to answer it. So like I'm gonna give you 2 minutes to answer it because some of these questions you're gonna have to write down some formulas and equate. So I'm gonna give you like 2 minutes. But whenever you're ready, you can just give me the answer.
I think it's D, sir.
Sorry?
D.
D.
Yes,
Uh,
sir.
uh. So what makes you like, can you explain to me why you think it's D?
I can't, sir. I just imagine two balls like
They're gonna
moving and then
collide?
the one stops. Yes.
Okay.
And then I don't know.
But for me, I think it's A or B.
I wanted to say A, but I I didn't know if I could. I don't know. I didn't want to say that the balls were unequal because it
You,
seemed wrong.
you mean the mass?
Yeah, the mass of the balls. I didn't. I don't know. I felt like it was wrong.
Um,
But my
so
first answer was
so let's just say you have moving in this direction and N was stationary. So N is not moving. So what happens is that M is gonna collide with this. And same time as it collides, it's gonna come to a stop. Then all that force is driven into N. Hmm. Yeah, it's gonna be C. So I think we're both wrong because if you look at it, if you look at it, the masses have to be equal. So as M collides with N, all that energy that M had is gonna go to N. So since the speed is the same, like if the speed was changed, then probably kinetic energy wouldn't be conserved. But the speed is the same, so kinetic energy is conserved. And since there's no external forces, the total momentum is also conserved. So if the frequencies are the same, because the initial frequency of M is gonna be V, and the final frequency of M is gonna be 0. The initial frequency of N is gonna be 0, and the final frequency of N is gonna be V. So the mass has to be the same because let's say how what example can I use? Um nah man. Honestly, like I'm trying to think of an example, but I can't come up with one now. But let's just move. We'll just go through our answers after. So you said it's D, and I'm assuming C, but let's move. They say a small stone is dropped from rest and undergoes free fall. Which of the following graphs show the relationship between potential energy and kinetic energy? potential energy and speed V, and the kinetic energy and speed V, respectively, for the stone. So in this case, when the stone is dropped, we know that the potential energy is gonna start off high and it's gonna lower. It's gonna go down as the kinetic energy increases. So now I think our main question should be about the shape, because from the looks of it, you know that D is incorrect, because if potential energy is decreasing like this, kinetic energy can't be increasing as a curve if potential energy is decreasing linearly. So personally, I think your answer is gonna be B. I think that they're both gonna increase and decrease linearly, but do you want to like give your input?
I was also gonna say B, so
Okay. Oh, I hope I hope we're both not wrong. But anyway, they say a stationary passenger at a railway station listens to a train approaching at constant speed. Which of the following for the sound of the approaching train heard by the stationary passenger? So the train is approaching a constant speed. So they want to know something about the sound. So they say approaching by the stationary passenger. The stationary passenger hears a lower pitch at a lower frequency, a higher pitch at a lower frequency, a higher pitch at a higher frequency, or a lower pitch at a higher frequency. So I'm gonna give you let me just give you like 2 minutes to work it out. Then you'll give me your input. Is that fine?
yes, sir, that's fine.
Okay. So I'm gonna give you 2 minutes. Oh.
I think it's C, sir.
C. So it's gonna be a high pitch at a high frequency.
Yes, sir.
So it's approaching. So the pitch is gonna be higher. So yeah, I think pitch and frequency are directly proportional. So if it was gonna be lower, it will be when the train is moving away from the passenger. So we're gonna leave it as C. As they say, particle P has a charge Q and particle R has a charge of 2Q. And they are separated by the distance R. And they want to know which of the following statement about the electrostatic forces FPR, which P exerts on R and which R exerts on P is correct. So they say P exerts half the force that R exerts on P. I'm sorry, P exerts half the force that R exerts on P. The electrostatic force that they exert is equal. P exerts 2 times the force that R exerts on P. And the force that P exerts on R is equal to the negative of the force that R exerts on P. So since R has double the charge of P, I'm gonna say P exerts half of the charge that R would exert on P. Just from like looking at the situation. So we have 6 minutes left and 3 questions left. So they say, so here's another question. Here's a question based on vectors. They say a battery of EMF E and negligible resistance is connected to a circuit, and the resistance of R2 and R1 are high. Which of the following combinations about the ammeter reading would be correct when the switch is open and when the switch is closed? So you can see that R1 and R2, sorry, R2 and R1 are in series. And if you look at this switch, I don't think it really affects it affects the circuit in any type of way, because if current is gonna move, it's gonna be something like this, then it's gonna move down here, then it's gonna move here, like that, and this is open, so it will not need to move into that. It can still go to the R1 resistor. So I think the conditions when the switch is open and when the switch is closed are basically going to be the same. So they say when the switch is open, the ammeter reads only the current in R1. When the switch is closed, the ammeter reads only the current in R2. That's false. So when the switch is open, it reads only the current in R2. Ammeter reads only the current in both of them. But here, if you can look at it, R1 is also there, so it also affects the current. So what I think the answer is, it's going to be C, because both R1 and R2 affect the current in both situations, regardless of whether the switch is open or closed. So do you understand that?
Yes, sir.
So they say the direction of induced current in a coil generator depends on the length of the coil, the speed of rotation, direction of the magnetic field, and the strength of the magnetic field. Basically, we're talking about direction. We're not talking about the strength. We're not talking about the amount of current. So this is the only thing that affects the direction. This affects the magnitude of the current. This also affects the magnitude, and this also affects the magnitude. So this is the only one that's gonna affect the direction of the current. The work function of zinc is greater than that of magnesium. So they say they want you to relate the work function to threshold frequency. So if you remember, work function, that's gonna be your H multiplied by your threshold frequency. So if the work function for zinc is higher than that of magnesium, automatically, because H is a constant, that means automatically your threshold frequency is the only one that's gonna change. And your work function is directly proportional to your threshold frequency. So obviously the threshold frequency of zinc will be higher, will be greater than that of magnesium because of the work function. And here they just say the threshold frequencies are independent of work, which is a lie. Oh yeah, sorry, which is false. And here they say they're gonna have the same, which is also false, because work function clearly is affected by the frequency. So since we have like 1 minute left, I'm gonna end it here, then start a new one. Then we're gonna go through the answers, the memorandum.